In Unit 2.3, we will be discussing the correlation method as well as other statistical reasoning and research ethics. It is important to note that the correlation method utilizes statistics. Before we continue on to the correlation method, we need to first differentiate the two types of purposes of statistics. The first is descriptive statistics. This is statistical procedures that we use to describe the population we are studying. Descriptive statistics are useful and serviceable if you do not need to extend your results to any larger group. However, much of social sciences tend to include social studies that give us universal truths about segments of the population. So descriptive statistics would be like the mean, median, mode, for example. Inferential statistics, in contrast, is concerned with making predictions or inferences about a population from observations and analysis of a sample of that population. That is, we can take the results of any analysis using a sample and can generalize it to the larger population that the sample represents. This is the correlation method. The correlation method is a measure of the extent to which two variables or factors vary together, and thus of how well either factor predicts or relates to the other. In other words, it assesses the extent to which two variables relate to one another. For example, in the summertime in Texas, the temperature goes up. All right, obviously. But with that knowledge, what then can we predict will happen to ice cream sales? Will they too go up, or would the ice cream sales decline? Well, in the summertime in Texas, ice cream sales typically go up. This is known as a positive correlation. The reason it is called a positive correlation is because these two variables, temperature and ice cream sales, are directly related, meaning that when one increases, the other also increases in turn. Does this mean that the high temperature in Texas causes ice cream sales to go up? No! The hot weather did not physically force you to go out and buy ice cream. You could have just as easily purchased a snow cone or a cold bottle of water. Ice cream sales go up in the summer because ice cream is very popular in American culture, and it happens to be more refreshing in the summer than in the wintertime. Memorize this. It is very important. Correlation is not causation. So what caused you to go buy the ice cream? I don't know. You went out, used money to buy it. The weather didn't force you to do that. You chose to. All right? But the weather and temperature sales are somewhat related, as we've seen, and that is correlation. It is not causation. So in another example, let's say it's wintertime in Michigan, and temperatures are plummeting to below freezing. Do you think the average resident in Michigan is wearing more or less clothing as a result? They are wearing significantly more clothing. This is called a negative correlation because the two variables of weather and clothing are inversely related. In other words, when one variable, weather, decreases in value, the other variable, clothing, increases in value, or vice versa. All right, this is an inverse relationship which leads toward a negative correlation. The correlation method also utilizes the tool of statistics to quantify or calculate the relationship between two variables. Do as many people in Texas eat ice cream in the summer as Michiganders wear warm clothing in the winter? I would think not. I would think that more Michiganders would wear warm clothing than Texans would eat ice cream. This means I believe that the Michigan-weather relationship has a higher absolute value. To help narrow down a more quantitative value for this problem, we use the correlation coefficient. This is a statistical measure of the extent to which two factors vary together, and thus of how well either factor predicts the other, or how well one predicts the other. The range for the corollary coefficient is from -1 to 1, as you can see in this graph. The positive correlation in the Texas weather example would probably produce a 0.65 corollary coefficient, meaning that 65% of Texans buy ice cream in the summer. The negative correlation in the Michigan weather example would probably produce a negative 0.95 corollary coefficient, which would be, remember, absolute value, which would be 95% of Michiganders wear warm clothing in the cold weather. Therefore, the Michiganer corollary coefficient is greater because you take absolute value into consideration, because we are referring to relationships. Scatter plots are how we plot positive and negative corollary coefficients on a graph. The chart below illustrates what negative, positive, and no correlations would look like on a plane. Fittingly, as you can see, positive correlations have a progressively upward or positive slope, whereas negative correlations have a more downward or negative slope. High to perfect correlations mean one variable will typically, if not always, precede or follow the other variable. Low to no correlations illustrates that the two variables are not closely related to each other. Research needs to watch out for what is called illusory correlations. This is the perception of a relationship where none actually exists. All right, so for example, the graph below illustrates the relationship between the number of people who died by becoming tangled in their bed sheets and the total revenue generated by skiing facilities. According to the graph, it appears there is a high positive correlation between the two variables. However, in reality, the two really have nothing to do with one another. If total revenue generated by skiing facilities goes up in the next year, it is not likely to cause or even relate to the increase in deaths by sheet tangulation. And yes, I just made that word up. Other statistical measures that you will need to know for the AP exam are those of mode, median, mean, and range. You may remember this from middle school, but just in case, we will briefly review. The mode is the most frequently occurring number within a list. All right, so from the list over here, what number is the most frequently occurring? It's obviously 1, because it's the only number that's repeated at least more than once. All right, so the mode of these numbers would be 1. The mean is the arithmetic average of a distribution, obtained by adding the scores and then dividing the number of scores. So if we added all of these numbers together and then divided the total by the amount of numbers there, so the sum would be divided by, let's see, there are 11 numbers. We divide the sum by 11, and then that will give us the average, or the mean. The median the median is the middle score in a distribution. All right, it's half the scores are above it and half are below it. So if you look here, the median is 5 because half of the numbers are above 5 and half of the numbers are below. So the median would be 5. The range is the difference between the highest and lowest scores in a distribution. So what's the difference between 1 and 10? The answer is 9. So the range would be 9. Standard deviation is very important to the AP exam. There is going to be a question on this. Not only the AP exam, but my exam as well. So standard deviation is a computed measure of how much scores vary around the mean score. In the image below, you will see a normal distribution curve, or more commonly known as the bell curve, for its similarity to a bell shape. The distribution curve is a natural phenomenon that can be found throughout academics, socioeconomic status, intelligence, and a plethora of statistical categories. But knowing how to read the graph and utilize the information it provides is essential. So let's look at the graph in more detail. While the number on the y-axis are not as significant to our current purposes, the other aspects of this graph are very significant. First, the O shape with the flag is the symbol for standard deviation, as you can see here. All right. What do you think is represented by the backwards U in the middle of the x-axis? It is the mean, or the average. The 1, 2, 3 and the negative 1, 2, 3 represent the percentage of the population that vary around the mean. To say one standard deviation would include the percentage of the population included in both negative and positive 1 standard deviation. To single out only positive or negative, you must specify positive or negative standard deviation. Beyond the third standard deviation are called outliers. These are the fast extremes of the population and are given what are called p-value. For example, if this graph represented the distribution of intelligence scores in a given population beyond negative 3%, standard deviation would be individuals with severe mental abnormalities and cannot function in society. Savants are included in this category. Conversely, individuals beyond the positive 3 standard deviation from the mean are classified as the smartest people in the world. We are talking geniuses like Stephen Hawking. All right? If you look in the middle of the graph, the mean, or the average, as you see here, is where you will find about 68% of the population. An overwhelming majority. You could say the average person is in the middle. Well, this is what makes them average. If you remember, a hypothesis is measuring data and measuring how likely that particular set of data is. The null hypothesis, however, refers to a general statement or default position that there is no relationship between two measured phenomena. For instance, a certain drug may reduce the chance of having a heart attack. Possible null hypotheses are this drug does not reduce the chances of having a heart attack, or this drug has no effect on the chances of having a heart attack. The test of the hypothesis consists of administering the drug to half of the people in the study group as a controlled experiment. If the data show a statistical significant change in the people receiving the drug, the null hypothesis is rejected. You only seek to disprove a null hypothesis. Statistical significance is a statistical statement of how likely it is that an obtained result occurred by chance. These tests are used to determine whether the outcome of a study would lead to a rejection of the null hypothesis based on a pre-specified low probability threshold called p-values, which can help an investigator to decide if a result contains sufficient information to cast doubt on the null hypothesis. Remember, p-values are the outliers on the standard distribution curve. P-values are the probability level which forms basis for deciding if results are statistically significant or not due to chance. So remember, making inferences. Number 1, representative samples are better than biased samples. 2, less variable observations are more reliable than those that are more variable. And then 3, more cases are better than fewer cases. The more samples you have, the more accurate your results will be. Hopefully you recall this from Unit 1B, Social Psychology. There have been many experiments that have had unintended profound adverse consequences for the research subjects. Remember the subjects in Milgram and Zimbardo studies? Many of the subjects suffered from PTSD, major depression, chronic anxiety because of these unchecked and unregulated experiments. Many research subjects' lives have been greatly damaged. IRBs, or independent review boards, were mandated in 1974 to ensure ethical standards for the physical and psychological safety of research subjects. In other words, an independent review board is a committee that has been formally designated to approve, monitor, and review biomedical and behavioral researches involving humans. Because of the many limitations that IRBs place on the study of humans, and rightly so, researchers have made use of the study of animals. As animals have similar biochemical structures as humans, many of the data derived from these studies are applicable to human behavior and biological functioning. We will explore how animal studies apply to human psychology further throughout the year. Here are a few ethical questions to consider. Read over these carefully as we will consider them and discuss them in class. And that concludes Unit 2.3.